Okay, I'm gonna start because that was a lot of just me writing and trying to get everything together, which hopefully you did um, in class. So hopefully you have all of this somewhere with maybe a little bit extra stuff in terms of the orange data. But here's everything we did this chapter. Okay, so the very first thing we did is we computed averages, and all of the average stuff is in blue. Okay, so we should be able to compute the mean, which is like the traditional average that you understand, right? It's the sum of all the data, right? So we also get a bunch of this terminology, right? So yeah, sum of all of the data over the number of pieces of data, right? So n is always going to be the number of pieces in the sample or in the population. Capital N has to do with population, lowercase n has to do with the sample. Okay. Population is denoted as that Greek letter mu. Sample is denoted as x bar. Okay. Median, that's just the middle value when you line all of them up in order. Mode is just the most repeated value in the data set. Okay. Mode doesn't have to exist. All of the others do. There's a couple of kind of tricks with median if there's an even number versus an odd number, but it should be relatively straightforward. Okay. That was section one. Section two is all about variation. So we find the range that is the max data value minus the min data value. There's the sample variance and sample standard deviation denoted over here, right? So variance, the sample variance, s squared, is the sum of the differences between each data point and the average squared. And then we take that over our sample size minus 1. And then standard deviation is just the square root of that. Population variance is pretty much the same thing. It's the sum of all of our data pieces minus the average squared, except this time it's just the size of the population. And then the standard deviation is the same thing. You just take the square root of that. Okay. We also did the Chebyshev interval, right? So basically what we need to know is that 75% of all of our data is going to be within, so it's going to be within 2 standard deviations of our mean. 88.9% is with 3 standard deviations and our mean. And then 93.9, so about 94%, is within 4 standard deviations of our mean. Then the last thing we did that lesson, which was really big, was the coefficient of variation. This is just to normalize things. Can't hear anything. You should be able to hear stuff. I'll keep talking and I'll try to figure out here in a second. But our coefficient of variation is just the standard deviation over our average. Besides that box and whisker plot, that's just the min value, the max value, Q1, Q3, and the median. And it's constructed like this, where Q1 is the value for which 25% of the data is below. Q3 is where 25% of the data is above. And then the median is just that middle value. Okay, so I'm hoping we understand all of this. But I'm going to leave this up here for a second, and I'll try and fix this. Okay, I didn't do anything different, but I can hear myself when I like I'm watching it back, so I think we're good. But if you still can't hear me, let me know. So we're gonna go ahead and go on. So this is all kind of the notes if you want to have a kind of a base for what you're doing. Hi, Tyler. That's new. We're going to go ahead and go through this Chapter 3 test, which, again, you can find it on campus. It's in that Chapter 3 topic, okay? Ideally, we were all able to all do this last class, but I want to go through kind of every single thing step by step. So first is find the 5-number summary of the following data and then make a box and whisker plot. So 5-number summary, I'm going to list these things in order, which is already done, just like a room. Okay, we have I was supposed to make that 10. We have 9 different pieces of data, okay? First thing we can get should be really obvious. That's the median, right? So this is the median. So on our box and whisker plot, we're going to have a min and a max, and we're going to have a median. And that median is 7. Our min is 2. Our max is 10. And what we need to do is we need to find the first and third quartiles, right? So if we split this up, 9 pieces of data divided by 4, right? That's 25%. That's 2 and a little extra, right? So our data piece would be right about here. So that's going to be 5, right? Because 25% of our data is 5 or below. The median we already know, so 2.25 plus 2.25. That would be our middle value. And then our max would be, hold on a second. Need to make sure I'm doing this right. Would be 9, right? Because 25% of our data is above 9 as well, right? So that's the box and whisker plot, and that's it for number 1, right? You can label these. That might help. Number 2, consider the sample data with sample average of 15 and sample standard deviation of 3. Compute the coefficient of variation. This is really easy. We just got to remember the equation. That's just S over X bar, which is 15. Oops, 3 over 15. Which is just 1/5. Compute a 75% Chebyshev interval around the sample mean, right? So sample mean is 15, and our Chebyshev interval says that 75% has our mean plus or minus 2 of our standard deviations, right? So we have X bar plus or minus 2 standard deviations, so 2 times 3. So that's 15 plus or minus 6, which is, that interval then is 15 plus 6, which is 21, to 15 minus 6, which is 9. So this would be our interval. So within 21 and 9, that's where 75% of our data is going to come. A job performance evaluation form has these categories: 1 excellent, 2 good, 3 satisfactory, 4 poor, and 5 unacceptable. Based on 15 client reviews, one employee had a median rating of 4 and a mode rating of 1. The employee was pleased that most clients had rated her as excellent. The supervisor said improvement was needed because at least half the clients had rated the employee at the poor or unacceptable level. Comment on the different perspectives. So if we just think about this, the mode, that's the most repeated. Okay, so of the things that repeated, excellent was the top one, but the median was a 4. So half of the data is going to be above 4. So most of the data is 4 and 5, or half the data is 4 and 5, and then the other half is 1, 2, and 3. So I would say that the employee, right? The employee is actually does need improvement. Because most of the data says that that employee needs improvement. Something along those lines. It's just asking you to take that data, kind of measure the variation, and then pinpoint where most of that data is coming from. Number 4, how hot does it get in Death Valley? The following data are taken from a study conducted by the National Park System, of which Death Valley is a unit. The ground temperature in Fahrenheit were taken from May to November in the vicinity of Furnace Creek. And I give you a bunch of data. All right, so that's all in degrees Fahrenheit. Compute the median, and the mode for all these ground temperatures. In order to do that, I'm going to line these up from least to greatest, right? So 144 is our minimum. 146. 152. 165. 168. 168. 174. 3 178s. 2 179s. There are 2 152s, by the way. Four 180s. 1, 2, 3, 4. Yep. Never in the wrong class. Always welcome. So we need to compute the median. That's, or actually we can do the mode first. So there are 4 180s. So mode is 180. So most of the temperatures recorded, most of the repeated temperatures recorded is 180. Median, we just need to line these up. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 17. So that gives us 178 is our mean, or median. And then our mean, we just add all these things up. And then divide by 17. So I'm going to do that on a calculator real quick. I realized I wasn't talking. So I wrote um, a couple of these terms, right? The average is 18.8. So we were taking the difference of all of our pieces of data and the average. We're squaring those, and then we're adding those all together, right? So 13.2 minus 18.8 squared, 5.6 minus 18.8 squared, 19.8 minus 18.8 squared, and then it'd be 15.05 minus 18.8, and so on and so forth. So now I'm going to mute myself, and then I'll get a number, and then we can divide that number by 8. So when I add all these things together, when I add the squares of all these things together, we get 493.03. We have to divide that by 8, and we get 61.63. Okay, so we did sample mean, we did sample variance, and now we need a sample standard deviation. So that's just S, which is the square root of S squared. So that's the square root of 61.63, which is 7.85. So 3 answers. We have our sample mean, our sample variance, and then our sample standard deviation. And then part B is asking us to compute a 75% Chebyshev interval around the mean. So again, all this means is that we are going to take our mean, so we have x bar plus or minus 2 sample standard deviations. So this is 18.8 plus or minus, and this is wrong term, so it should be 2s. So 18.8 plus or minus 7.85, and that interval is 18.8 plus 7.85, which is 26.65, and then 18.8 minus 7.85, which is 10.95. So that would be our interval. And then the last part, use the following to answer the question. So I'm giving you these 4 box and whisker plots, which is normally how they're kind of given, or at least sometimes. You have things side by side, and you can kind of see data in this way, right? So we have to be able to distinguish the medians, the ranges, and the quartiles. So part number 6 says estimate the median chick weight for diet 1. So the median, that is this bar, right? So I would say that that bar is probably like 160. It doesn't have to be exact, but it should be pretty close to 150, but not 150. So 160 works. Number 7, estimate the 5-number summary for diet 2. So the mean looks to be somewhere just below 50, so let's say like 40. I can label these. So our min is probably about 40, maybe 35, but we don't have to. Well, yeah, I'm not going to do 40. 40 seems too high. Let's do 30. Because half is about here. Another half is right there. Yeah, so 30. 30 works. The first quartile, so that's kind of right above that median. I'll do this in a different color. So it's just above 160, probably about 165 or 170. So Q1, we can say, is 165. The median, that's just above Q3 in red, probably about 220. And again, these numbers don't have to be exact, but they should be pretty close. Q3, that's this value right here. So probably like, right, that would be about 275, so just under that. So we could say 265. And then the max That's this value right there. So just above 325. We can say like 335 for that. And then that's our 5-number summary. Number 8, which diet would you say gives the most consistent results in chick weight and why? So this is talking about range. I'm going to leave this. I'm not going to answer this for you because a very similar one to this is going to be on the test. And I don't want you just to remember what I say and put it down. But this is asking kind of the range of data and the consistency of the data. So you have to think about what a box and whisker plot actually says, what the definition of all those things mean, and then kind of give your answer. Okay, so that is the entire test. It's going to be really, really similar to this. You will definitely have a question like this last page on the test. It's going to be really similar. Okay, all of these questions are going to be about the same, probably with different sets of data. You just have to show me that you know how to find mean, how you find variance and standard deviation, whether or not it be sample or population, right? So most of our computations have been sample. I would probably study up on population because I almost promise you that's going to show up. Mean, median, mode, those should be really straightforward. Kind of just interpreting the data, Chebyshev's interval, coefficient of variation, and then making your own box and whisker plots. So those are like the really, really important parts of the chapter. So that's what I'm testing you on. I'm going to kind of leave this open for a second and make sure people don't have questions. And if they don't, then we can end it there. Okay, so I'm going to mute myself for a couple minutes. And I'll probably scroll through slowly. And as you have questions, just go ahead and ask. Or if you just want to talk. This is boring when people don't interact and no one's had questions. So that'd be cool too. T-Rex indeed, Mason. T-Rex indeed. All right. It doesn't seem like people have questions, so I'm gonna close this in the next minute. Um, in which case, I'll see you tomorrow, and good luck.